Okay. So I only have to make it really big, otherwise the button doesn't work. Okay, that's fun. People thought I have a company, and I don't. I'm a freelancer, and someone asked me how the AirHacks company is, and there is no company, so I immediately registered AirHacks Industries. But if you look at AirHacks Industries, it's just links to my GitHub and a few other links. I really like Java. I'll do Java all the time. Today morning, tomorrow, so just Java everywhere. And from time to time on vacations, I'm speaking here at conferences. And so, why I'm here? Because of a guy called Ralf Soika. This is he, and I think it was Jakarta stream, and he commented something like, you know, Adam is not the same as 20 years ago. He really hates open source or whatever. And what I did back then, I explained serverless architectures, and didn't mention what I'm usually doing on premises. So the idea of this talk is to talk a little bit about two architectural styles, both with Jakarta EE, of course, and MicroProfile, but they are completely different. And in one, you know, open source and open source toolings matters a lot, and the other style matters a little bit less. You are invited to ask me questions, whatever you like. You know, if you say I'm not with you and challenge me, so I really like that. I'm not a speaker, I'm a developer, so I basically don't care, right? So it has to be fun. First Monday of the month, I'm answering all technical questions and also non-technical questions, but should be answered by me, Java related. And I have a YouTube channel, was also fun. So I'm recording daily Java shorts because someone said, you know, Python is complicated. Oh no, this is true. Java is complicated and Python is easy. And so okay, then show me what's complicated. And since then I'm writing in 60 seconds Java code from scratch, and nothing is complicated. So I have already 700 shorts. So you can have 700 minutes of Java snippets. Over this is old news, 700. So and some workshops. Okay, if you like, you can attend. And Java and clouds. Has nothing to do with the topic, but I always show the slide because Java is really great in the cloud. What it means is, if you take a look here, Java is number 5, performance and memory. No, memory not. Power consumption and memory not that great, which means with GraalVM we can fix that. But what also means is, if Java runs fast, we can save money, and if we can save money, we can run Java, and this is why I use only Java in the clouds, nothing else. All my Java projects are actually either Java SE or Jakarta EE related, nothing else. And Jakarta EE related, I will show you in a second what it actually means. So nowadays, platform engineering is the hot thing, right? Everyone talks, also there was DevOps a few years ago. No one cares about DevOps because the conferences are empty, so now comes platform engineering, basically very similar topic. But, and what I try to do is, they try to do the cloud easier. This is my impression. Everyone wanted to have clouds, and they are in the clouds, and then find out clouds can be expensive and are complicated. So we need something between the cloud and us, and so they defined platform. So we had the platform all the time, and my platform was J2E, what was JE, J2E, Java EE, and Jakarta EE. So it was never as easy. Even in the worst projects back then, Java EE, they were more or less serverless because there was one department running the servers, and we copied the war, and this was it, yeah, right? So this was my platform, and now they told, okay, application servers are too complicated, and therefore we need to go to lightweight clouds. And now we are in the clouds, and no one can use the clouds. So this is my impression a little bit. And everyone tries to abstract from the clouds because they found out the clouds are too complicated. So interesting. So the first finding is with Jakarta EE or MicroProfile, what I like about that is don't make me think. It means I have my platform. I don't talk about it like Linux. I don't have to think twice that I will run probably Linux in the cloud. So I also will run MicroProfile, Helidon, Micronaut, Payara, Glassfish, or something similar. I actually don't care because the API is everywhere the same, which is cool. So now, strategy. This is what I omitted in the in the session 2 years ago, and this was disaster because I didn't explain actually what I would like to achieve. What is a strategy? So a strategy, this is management, has diagnosis, guiding policy, and action plan. So if you go to the cloud without a strategy or remain on premise without a strategy, forget it completely. So we cannot talk about architectures. So it means, for instance, the reason why I'm spending so much time in the cloud right now is not because they are lean or nice or whatever. It's because in the pandemic, some law changed in Germany, and this disaster recovery was rated higher than before. So we had to go to the cloud in order to have 2 data centers which are farther apart than our private data center, for instance. So it means diagnosis, we have to go to the cloud. Guiding policy, we would like to pay the bills, right? So the budget is tight, so it has to work. And action plan was, and also guiding policies, if we go to the cloud, we try to improve the situation and not, have the same old boring technology premise. So, and now this was censorship. Maybe it was too much, so I will be a little bit nicer now. So, evolution of Java. So we had a chat with Daniel before the show here, and how Java started. So it started with proprietary solutions. There were not even collections there. Then we got standardizations. There was no Swing, no AWT, so we got that. And then something bad happened. XML became popular, so everything blew up. But for me, it was great. Lots of projects because no one could actually know what they are. This was crazy. It was an evil book, Java and XML from O'Reilly. So it caused, for the next 10 years, absolutely no disaster. And so then it was really popular, and then open source happened. So Whitefly and JBoss, right? They were how to call it? They actually won the battle with commercial application servers, and then everything had to be vendor neutral. And this is very important for architecture, because what it means is in all my projects, they forgot the clients and customers and tried to decouple from the vendors. And but they also forgot about the clients. So some such projects were not very successful. Actually, I'm still doing some code reviews right now in projects with 20 layers just to decouple from the database, but the database never changed, for instance, right? And what is the outcome? The outcome is, because to change one variable in Java, they have to touch 50 layers. It takes too long. And then Python and JavaScript and Go or whatever came without 50 layers, and they say, okay, look, they are productive. It's like, yeah, but they don't have 50 layers, right? So only one. So now, the API and SPI guiding practice. So we have API, JDBC, API, and SPI is Postgres driver. Okay, so this is, or we have JAX-RS is API, and SPI is Jersey, or REST easy. Okay, you're acquired, so you can ask me questions always, right? So otherwise, it's boring. Jakarta EE and MicroProfile, for me, is the same. I know this is not politically correct, but I don't care actually, because if you go to the MicroProfile spec, this Jakarta EE is the core profile, and this is what I mostly use in all my projects. People on Twitter ask me, are you still using Java EE? It's like, yeah, but I cannot tell you every day you create a tweet, I'm still using Jakarta EE. I mean, what I can tell, I just use it. Like, I'm also using Linux, and I'm still using Java, and I'm compiling my code, right? So, but what I'm mostly using is subset of CDI, subset of JSON-P, sometimes JSON-B. Is not like I'm using everything. So this change a bit. And what I'm using depends on the context. In private clouds, we use more. In public clouds, we use less. So this is the main difference. And why there is? Not because public clouds are some different, I don't know, cloud native requirements, rather than if you do the same what you do on premise, you cannot pay for public cloud. So lift and shift, you can do maybe twice, and then budget is over. So you have to behave differently in public cloud. So this is the reason. Questions? No. There are some interesting components. So right now in projects, we have a huge project which is completely serverless, completely based on Jakarta EE or MicroProfile, whatever you call it. We use dependency injection, interceptors, JSON processing, JSON binding less, because if you have complex data structures and high requirements regarding versioning, with JSON-P it is easier. And at the beginning, JSON-B is easier, but if the project grows larger, JSON-P. And Jakarta RESTful Web Services is everywhere, basically. What I didn't use for years, I have to admit, is SOAP. But yeah, and except, in the restroom, you have to sometimes SOAP, but usually really, but not in my IDE. So on-premise architectures. So the defining hardware was this Sun Starfire. This was E10K. So I liked the machine. I wanted actually to buy one prior to pandemic, and it cost 2,000 euros after the fact, so I could buy this. but this was in Australia, and shipping was more expensive than the machine. So I just wanted for my clothes, you know, because you cannot use it anymore. And this is the new version of it. I don't know whether you know. It's called Oxide or Oxid. Nothing to do with the company, but cool stuff. Prior Sun Microsystem people built an on-premise cloud computer, basically, and crazy stuff. So, and if I would imagine, private cloud, if you have such a thing, would be cool, right? This one is not that cool anymore because I think, your watch is more powerful than this machine. But yeah. Now, Java on premises. What you could do, really, let's say we would like to have a successful project. So what happened is, usually I would say, you don't have ARM. You will have to live with Intel or AMD. This is the first major difference to public clouds. Then you have hopefully high-end hardware. Why? Because in the cloud you pay for Raspberry Pi 50 euros a month. This is actually the truth. If you buy EC2 machine, which is comparable with Raspberry Pi, you will pay 50 euros, and maybe you can start a database on it, but so half, right? So and then it runs on Sundays maybe. So on premise, usually hardware is cheap. I still buy hardware and buy my own servers, and it's really cheap. So I would expect to have more RAM and more CPUs, and not as crazy as in public clouds. What means to me is on premise, you have to run virtual threads. In public clouds, virtual threads makes less sense. Agreed? Because on premise, you get beefier machine, you can have hundreds, millions of threads. In a public cloud, you could have these threads, but it is harder to pay for them. Agreed? Any questions? There's a quiet audience. So then Project Loom, Docker and layering. In all my projects, we have own layers. And this is actually cool with application servers. What you can do is you can have your own layer still with Helidon, Payara, Quarkus, whatever you like, is the super layer. You inherit from it, and this is only your application code. And in some successful projects, I have Docker Compose here on screen, and this is not a joke. I know a production system which runs for years. This is a production, that means robots, welding, with Docker Compose, no Kubernetes, and they are happy. But they have only such project. Why not? Right? You can be more pragmatic. You don't have to use Kubernetes with 500 pods. You can be very successful with a single Docker. Then GraalVM is an option, or I would say on-premise is a must. In all projects I know which run OpenShift, Kubernetes, similar stuff like OpenShift or Rancher on-premise, they saved a considerable amount of money, RAM, and of course power with GraalVM because it reduces the RAM consumption. And crack is good for you. So this is an exception here with Java. And what it is coordinated restore a checkpoint, part of the OpenJDK. I always wanted to say resources, restore a checkpoint. And what you can do is you can freeze more or less the JVM in a blob and restore it very quickly so it starts faster. So I will use it. This would be my research on-premise projects because you can do it easily on-premise and mission impossible in the cloud, or really hard in the cloud. So this is the strategy. If I stay on-premise, I would build, cool on-premise projects. And if I go to the cloud, I use the cloud. What seems to me, what people are doing is they have, a virtual machine on-premise and then ship it to the cloud, and they say, now we're cloud native, and everything is 10 times more expensive, no added value, and they say, what do we do now? Maybe we should go back. Okay? Still no questions? Then, Java Flight Recorder, in my opinion, on-premise has to be turned on. There is actually no downside. Build your custom events. You get real-time monitoring for free. In the cloud, such a monitoring would be extremely expensive. Logging in the cloud, 40, 50% of your bill is logging. Okay? Still no questions. Then next slide. I don't know whether I will code. If not, I will record a screencast with it, right? Because I only have 20 minutes or something, but yeah. So Java on premises, I would expect real-time monitoring, extensive logging. Extensive means you don't ask anyone for the cost. You can just log. You can use supported OpenJDK distributions. This is what I will advise. If something goes south, you can call people which help you with the support. And if you run Kubernetes, what I would expect on premise, you have a Kubernetes operator. If you have a complex system, you can extend Kubernetes and launch your entire microservice stack in a defined order. So this is more like a product. You know, your cloud is your, how to call it, differentiations factor, and you cannot do this in the cloud easily. Okay. So on premises, we have more or less stateful architectures. We have load balancer. We can configure the load balancer, and we can even have, if we really like, JSession ID. We don't like, but we could. In the cloud, almost impossible. So it's really hard to implement the ALB, for instance, for that. So we can use pooling and caching on premise, and we can have a crazy caching. For instance, we can use InfiniSpan or whatever we have, and we can make it run. In the cloud is far more restrictive, you know, with the VPCs and the networking. But on premise, why not? Managed Kubernetes, I wouldn't run my own Kubernetes. I would buy one, Rancher or again OpenShift or whatever. And open source services and databases. I would say on premise, the usual stack has to be Kubernetes. I'm not sure about the serverless Kubernetes extension. They don't make less sense on premise because none of my clients complain that they have too much hardware. There's always the hardware is limited. And if you start with serverless, it doesn't make any sense in my eyes. But if you see something, then we can talk about. So you have Kubernetes, and then, you know, Kafka, Prometheus, and whatever we talked the last 30 years is normal. Postgres database, the open source stack makes absolute sense on premise. And this was the missing part of my talk for Jakarta livestream, where Ralph said, you know, I'm now, I don't know, anti-open source, right? But I invited him to my AX FM podcast, and everything is fine now. But it was the impression that that I'm anti-open source. But now it comes in public cloud, it's a completely different story. So now you can do super cool stuff. For instance, if you have Azul OpenJDK, you could use, for instance, Azul Code Inventory. And what it does is you can run, it is, you can start your application on Azul Code Inventory, run your tests, and you get code coverage for free, for instance. If you don't have it, so you can run Jacoco from Eclipse, you get similar output. And then Panama, Babylon, Vector API, Project Laden. So the next thing on the horizon, or not on the horizon, are already there, is LLMs and AI stuff. So less exciting, or completely misunderstood in enterprise. Why that is because what people or developers or managers are expecting, like, you know, the how to call it, the auto-completion text which runs over the screen. How to call it? You know this ChatGPT with answers with the ticker-like style. We never did that. So if we talk to LLM or AI, what we are doing, we are expecting a microservice like API. We pass on JSON, and what I would like to have back is enum. Is it fraud or not? Or maybe, you know, from 0 to 100, how likely it is that the input is not okay. Now, and the interesting part is now, what we can do with Java. There are two interesting projects. One is called JLlama, and the other is Llama 3 Java. And this is what actually is really interesting. You can run offline without cloud. You can load directly to Java the model, the weights, and run it. And now it comes. We have in MicroProfile request scoped, conversation scope, application scopes. And if you think about conversation scope and about the chat memory, they are not that different. So what it means, by lucky accident, actually, MicroProfile and LLMs are perfect. The speaker after me will talk about circuit breaker, he told me. And what's interesting is about fault tolerance. Fault tolerance is the best spec for LLMs. Why that? Because I don't know whether you've worked with LLM. So I have Claude and ChatGPT. I have commercial API. And the most common error is 5 to 9, you are throttled. Right? With circuit breaker, no circuit breaker, how it's called, not repeat. I always, not repeat, rather retry. Retry, you get it for free, it will repeat until it works. Right? You can have fallback. You can try with the mighty model. If it doesn't work, you can pick one model with fallback method, another one. So this is actually great story. And what companies love about that is they have already running MicroProfile in Jakarta EE systems. The question is how to integrate with LLM. They're already afraid that we need to know GNI, C, and Python, whatever. We do nothing. We have a native right now Java integration, and it gets better with projects like Babylon with direct GPU integration. Vector API is already there, and this is what I'm talking about. And on my YouTube channel, I already showed you how it works. And the cool story is, with the Llama 3 Java, you don't even have to compile Java. You can run those Java and it runs. So you have your own ChatGPT. Questions? No. Project Leiden. What it does, you can specify how fast Java starts, or how fast or how good is optimized. So this also makes more sense in, or is only possible in the private clouds. For instance, on my AWS Lambda, I can specify such things, but usually I disable the garbage collection completely, for instance. Okay, so on-premise, everything is open source. Vendor neutrality is a thing. Maybe I would like to replace Postgres not with, I don't know, MySQL. More likely is Postgres is Neon, which is a serverless flavor of Postgres, for instance. So then multiple layers, unfortunately, of bloat, I would say get rid of it. So it should be to the point. We have still project with lots of Maven modules. I don't understand why. All modules the same versions. So okay, then we don't need modules. And actually, on premises, everything is interesting. What is less appealing is JSF. So what I see over time right now, actually without reasons, JSF is used less. But what I'm suspecting that we get in the next 2 years server-side Java rendering technology, and it happens more and more because even the Node.js and the JavaScript toolkits find out, okay, we need something on the server, and we had it on the server 30 years ago, but forgot about it, right? So we have just, to revive it. Jasper project, I always wanted, to do it. For instance, my blog I have rewritten on a weekend. It is basically multi-line string with replace all in my old template language, which is very trivial, but enough for a blog, for instance, right? So rethinking design to be effective. So what you have to do is you have to think in business first. So this is actually the main effort. So what we are building. Then everything is synchronous, nothing asynchronous. I know asynchronous is cool, but it's very complex to understand. So if synchronous works, you are set. Don't distribute. No third-party dependencies. Right now, I have to justify in an important project how we mitigate the risk of external vulnerabilities. And the cool story is we are Jakarta on Lambda. And what it means is we don't have operating system. We don't have to JDK. We only use MicroProfile and Jakarta dependencies. It means in one paragraph, I'm able to describe no problem. But imagine I would use Kubernetes, then I have to justify the entire stack. And this is almost mission impossible. So for me, it is bad right now because in a 1 hour assignment, I'm done. I'm a consultant. With Kubernetes, I can charge them 2 weeks, to explain the same, right? So use the platform. So, and Jakarta is nice, but I'm doing more and more. I'm replacing Jakarta with Java. So if there is a HTTP 11 client, and this is good enough, I will pick that instead of MicroProfile REST client, for instance, right? So there is no reason to use Jakarta. Of course, there's reasons, but in trivial cases, you can stick with Java is even better. So Java SE features first, very simple code first, prefer Java SE libraries, base64 is in Java, string is blank, you don't need, Jakarta Commons lang. Logging, I use Java system logger. It ships with Java, there's no external dependencies. And virtual threads, record classes, deconstruction, everything is there. And data-oriented programming is then the next bigger thing. What it basically means is you have an interface which is a sealed interface with implementations with the Java records in a switch case, which is an expression, and this is actually the opposite of object orientation, but works perfectly with Kafka, messaging, and NoSQL databases. Rethinking architectures means everything is simple, and Yagnis, you aren't gonna need it. So this is an old Ruby on Rails meme. And start with nice monolith. Actually, I'm still doing this. I'm writing monolith for 20 years, and from time to time I rename them. So 10 years ago, I called my monolith microservice. And before that, I called the monolith shared nothing architecture, and now I don't know how we call it anymore. I just call it monolith, and everyone is happy. So it seems like monolith is the next big thing. If you say you're writing a monolith, you get invited to conferences. That's my impression right now. So and reactive programming is dead, more or less, because we have Project Loom, And reactive programming is only in rare cases. Interesting. We have so reactive expert here, so don't kill me. But when I would use reactive programming, if I have Kafka, as the events coming to me, then the reactive API is perfect. Or I will have building something like a load balancer, and I'm calling different, but I'm not building load balancers. So this is, I would say, you need reactive programming in less and less cases. I'm kind of right, Daniel? Oh, I thought he would say what he's the reactive Helidon guru. So therefore, if he said right, then of course we can stop. I can stop talking now, right? So use standards big for me. So MicroProfile in Jakarta EE is a must, and I'm even more picky. I pick MicroProfile in Jakarta EE core before I pick the standalone projects. And why that? Because of buzz factor, right? So you could use, for instance, Quarkus Mutiny, but Quarkus Mutiny is not an official, I would say, MicroProfile standard, and therefore used by less implementations. If used by less implementations, the chances are higher that it will die one time, okay? And a standard means multiple implementations, so it's easier to switch from Quarkus to Helidon, for instance, right? So this is why I like Quarkus, because I say, okay, if Red Hat behaves strange, we can go to Helidon. And I know it will work, right? So this is the cool story. Okay, recap, as simple as possible, Java 21 features and so forth. Now public cloud architecture. This is where my trouble started, because in the other talk, Jakarta talk, I only talk about that. So, motivation facts. So the motivation is, if you have Helidon or Quarkus, and it responds in 100 milliseconds, hint, on the Lambda it will respond under 10 milliseconds actually, so this is exaggerated. And it runs 2 transactions per second the entire month, and it is 2 gigs of RAM, you will pay $15. So with this slide, this is my entry point to all projects. So this is 80% of projects look like this by Lambdas, AWS Lambda. And just because of costs. That's all. And this fits perfectly for enterprises, fits less well with Netflix. Because this works well if you have peaks and nothing, which is typical enterprise project, right? At night, nothing happened. Actually, I had a talk here, not here at the JAX, it was near Munich, and one guy from a big company in the near, they applied that and they say they pay 50 euros a month, and this is the biggest projects they have. Okay? So, and they are very happy. Okay, it means in the cloud, in my cloud projects, everything starts with an Excel sheet. So if they start in the cloud, they would like to know how expensive it is. So this is the first question. And the entire architecture is based on costs. Complete different story to on-premise. So, and in the cloud, I would like to have no ops. Because why? In the cloud, I'm in charge of the application. I have to run it. So I'm absolutely not interested in the night patching operating system of Kubernetes. What can happen? So it means for me, the only real improvement in cloud is serverless. And serverless means I don't care about the infrastructure. I would only like to push my war somewhere. This is what we did for years on premise with Java EE, Jakarta EE, and MicroProfile. This is what made me excited back then, right? This is our platform. And this no ops is a good thing, and it is true. In our current projects, we have AWS Lambda, we have S3. On Azure would be Azure Functions and blob storage. And the interesting part is there is nothing to operate. How to reboot an S3 bucket? It just runs. There is no way to destroy it or overload it. Impossible. How to debug a Lambda? I mean, it comes and go. It self-healing. It means nothing to operate. Even better, because on Azure and on Amazon and the other clouds as well, what happens is they managed JDK for you, they patch it for you, for instance. So this was the reason why I was able to introduce Lambda to serverless. Why? Because AWS patched the log4j issue proactively without doing anything. So even if we had log4j, there was nothing to do because of patch in the cloud. Okay? So, and this means, this is the strategy. If I go to the cloud, I would really see improvement. And if I'm on premise, I would like to have the complete control and use the really great features of Java. Everyone agreed? And if something is not possible, then manager will tell me, and then there is some compromise, whatever. But I don't like compromises first. So what is the best thing in the cloud, and what is the best thing on premise? So, and this is actually, serverless is more expensive than whatever you have in the cloud. So, why is that? Because there are more stacks involved. So if you just run, EC2 machine and the same load on Lambda, Lambda will be 30% more expensive than EC2 machine. But with serverless, you get the perfect auto-scaling. And this is what it makes it cheap. You only pay for what you use. And if you have a non-serverless environment, you have always over-provision, and this is what you pay for. And with what also happened, in serverless, we can have as many environments we like because they are free. Every developer can have a production-like environment. In Kubernetes, in theory, yes, but you will have to pay 100 euros for the control plane in every environment, at least, just for the control plane. Okay, cloud lock-in. So there are two things. We could write our own platform. We can run, which you have, application server, if you will. And I'm actually not interested in it, because what interests me is not to be portable. What interests me is how long it takes to switch from Azure to AWS, or from AWS to Oracle Cloud, or I don't care where. Even if I'm absolutely not portable, but the code is simple, I don't care. And this is our strategy right now. We write simple code in the cloud. Our business logic runs on MicroProfile and Jakarta EE, is completely decoupled from the cloud, the business logic, and the infrastructure is completely dependent on the cloud, but the cloud services are very similar. For instance, Azure App Service is similar to ECS Fargate. So if I have to migrate it from one to the other, it's the matter of rebuilding the Docker image, basically. Okay, so what it means is boring. If you say I like all my stacks, you could do this. But I think what should be is that the cloud does everything, and we just running, the business logic. And what Oracle has to do is have Java functions on steroids. So they only ship a Java source code, and is automatically invoked by someone. This would be actually even a step further, which they have kind of, because GraalVM has isolates, and this is such a thing. So it's really interesting. If you're interested in such serverless stuff, GraalVM isolates. Okay, fat monolithic function means in the cloud, I'm mostly, so I reviewed the project using the right stack, Jakarta Core MicroProfile. It means my cloud deployment is right now mostly Quarkus, and it uses JAX-RS, JSONP, sometimes bin validation, always config MicroProfile config, and sometimes JSON Web Token specification. And what's interesting is authentication authorization must not be used in the cloud at all. Why? Because authentication and authorization is usually implemented by load balancers on API gateways. And if you are cloud native, you're using the services, and these services are doing this for you, but the services giving you the token, right? So this is what happens, or should happen in the cloud. Otherwise, you don't have the application load balancer, and you're running your own application load balancer. So I ask you why you're in the cloud in the first place. So you did it at home, so stay at home. Also fine. Cool. So how it looks like, the Jakarta EE servers are basically Lambda. So the only difference is there is no multi-threading. So virtual threads don't make any sense. One, this is process scaling. What we have here, we have a kind of application load balancer. This can be application load, but it says complete different names. I forgot the Azure name. On AWS, there is an application load balancer, HTTP API gateway. There are 3 flavors of that, and they are exposing HTTP endpoints and waiting. And what they are doing, they are translating the HTTP call to a JSON event, and this JSON event is passed to the Lambda runtime. So I had a chat with Dimitro from Helidon, and he promised me 5 years ago Helidon will support it as AWS Lambda, so I'm waiting for it. But Quarkus is able to do that. So what Quarkus does is, Quarkus parses the JSON and invokes the JAX-RS interface. And this is why we are completely independent in the cloud from the cloud. For me, the code looks like 20-year-old Glassfish project. No difference. This is the entire trick, which is great. Okay? So, that's basically all. And if we say this is not a Lambda runtime, then it's a Docker. What is the difference? You have multi-threading. In this, there is no multi-threading. There will be never 2 threads in a Lambda, which is identical to EJBs, the behavior. So if you know EJBs, you are the Lambda expert. Good news, right? Back in the game. So serverless archive is not on ERs, it's on SAR, and this is the next best practice. So what we are doing, actually, we have one entry point Lambda and 10 other Lambdas in one big Maven jar project, and we're deploying this several times as multiple Lambdas. But the cool story is, first, Java is crazy fast. The amount of classes doesn't matter. So there is no direct correlation between startup time and amount of classes because it's still tiny. We have a project with several hundred classes and still starts fast. You have to be cautious with dependencies, but we had it already. But it's its own code, not a problem. And the cool story is we get atomic deployments. So it is deployed once, right? Entirely or never. And now it comes. We can share code between Lambdas. And we have the entire Jakarta EE and MicroProfile spec inside. So it works that well that the developers forget that we are in serverless environment. And with Quarkus, and if Dimitro next vacations in Helidon, we could run it locally. So we do with Quarkus, we can debug, run everything locally, or ship it as Lambda. So I got a question from AWS, what my local stack, the test story. It's like, I don't need it because we can just debug everything on locally, and they were amazed, but it works with Quarkus out of the box. And soon with Helidon, of course. So Micronaut is also the same. So the ultimate structure, for years, the same boundary control entity. And I have just 1 minute, so this is old. Test strategy, also cool. What we do, maybe next talk, next time, we treat tests as an application. This is the best explanation. So we completely reuse tests, and we are crazy fast with system tests. So we use Quarkus, or we could use Helidon in this particular case, and inject into tests our MicroProfile REST client interfaces and make everything reusable and really fast. Not fast, productive, how to call it, fast from development. So this is not a new concept, but it works well. Imagine this, maybe cool, short explanation. So imagine we are building a conference management system, CMS, conference management system, and we have create talk, then assign speaker to talk or whatever, right? So if you imagine, we are testing the create talk, right, first. So then we have functionality create talk. But this create talk comes over and over again because we need the create talk for the speaker, and create talk for the rooms maybe. So what we're doing is we are moving from source test Java, the talk code, to source main Java and make it injectable everywhere. And then we are refining the source main Java, and then we get faster and faster. We have almost like a DSL. The longer the projects, the better the tests. Okay. Now some code, no code. So because we have just 2 minutes. But I will record the code. But what I wanted actually, the main difference is now, in the public cloud, we never used so far, if we started from scratch, relational databases. Now the question is why? And the answer is because of the costs. Relational databases are not serverless, usually. Even if they are told to be, in the name they're serverless, they are not really serverless, which means for a Raspberry Pi database, you will pay 300, 400 euros a month without backup. With backup, 800 euros a month. Okay? If I show this on the Excel sheet in the first day, the project will die. Or the question is, the manager asks me, are you crazy? So no, crazy. I'm not the cloud manager, right? I'm just developer. So what you can do, therefore, we never use such a things. Kafka the same. If you run Kafka, 3 Raspberry Pi broker, 500 euros a month. So what we do instead, we use in the cloud proprietary managed services. So instead of Kafka, we use Kinesis. Instead of GMS, we use SNS and SQS. Instead of Postgres database, RDS, we use DynamoDB or S3. So what means is we use less JDBC, we don't use JPA, we don't use Jakarta just because of the costs. Okay? What also means is from Jakarta we use HTTP a lot because all managed services in the cloud are accessible via HTTP. If you call something, it's always HTTP. And if the service is an open source service, it is not HTTP, it is binary. JDBC, binary. Kafka, binary. Okay? So, and this is the main difference. This is why, really, if you think about this, public cloud architectures and private cloud architectures are the opposite. There's complete opposite of the pole, because your strategy, cloud strategy, is completely different to private cloud strategy. It has to be. And this is why I don't believe in lift and shift. If you do lift and shift, this is like, you know, short-term solution. In longer term, something has to change, because either it is way too expensive or there are absolute no benefits. And if there are no benefits, you know, if the economy goes down, there will be questions to be answered. And the question is, why are you doing this? And if there is no answer, it's the beginning of the end. I think I'm over time, or at least. Is it -5 or is it I have 5? How is, you don't know it? So I'm good, huh? I'm good. So questions. I think 5 minutes to go, right? What it says. Yeah. Any questions? 5 minutes for questions. And what I have here, this is embedded glassfish from Jakarta. I played with it. So started. This was the glassfish 7 with Jakarta EE. Helidon starts, of course, a little bit faster, I guess. So this has to be cut out. And Quark is also, everything is fast. It doesn't matter. Okay? So this was just a start. So now, what I also did yesterday, there's Jakarta Essentials. I say, okay, what is the modern POM of that? So I maintain that, and this would be the entire Maven POM to be productive with Jakarta. Okay? And I have here a project. So this is, of course, rockets with some emojis. So emojis are also supported in Jakarta, no problem. And so this is how it looks like. Okay? So now, to build a thing, right? I have to go here and say Maven package. It's packaged. And the cool story is, if you are really strict, it will be nevermore. This Jakarta API is the entire API from Jakarta. So there is nothing inside, which is especially interesting for security reasons, dependencies, whatever, boost factor, whatever, right? It's still a thing. So, and if you go here, and this is the entire app, and we take a look at that, you will see that the entire war are 3 kilobytes. Because everything else is in the server I started. Okay? So, and in the cloud, what I'm doing is similar. So if I go here, I would say Quarkus create, and let's call it OCX. So this is Quarkus with JAX-ORES and MicroProfile. It ships out of the box, and it took a longer time because it tried to resync, tried to update the version. And there should be a OCX project. And if I open that, you will find source main Java. Also this, unfortunately, without emojis, but it's exactly the same code as you see. And what I can do here, I can also say Maven Quarkus dev, and it will run in dev mode. And with additional, this was a slow start because it's dev mode. Yeah. And so to give you an impression, and what I could show you actually if I had more time is to have one code which runs on bare metal, in Docker, and serverless Lambda, for instance, without any differences. And this is one business code, which is actually a dream, right? If you think about this. And with the very first slide in Java, we can actually prove to management that with Java, we can actually save money. Because unless we use C or Rust or whatever. By the way, what I forgot to mention on the first slide, Python and Ruby are 35 times slower than Java It means if you do CPU-based calculations there, you will pay 35 times more. But if you do nothing, Java, just I/O, then of course it doesn't matter, but then it does matter, right? So I would say thank you, and see you next time. And next time maybe with tests or whatever, but I think we clarified, this was what's the big difference between cloud and on-premise, and if you have a strategy, it becomes maintainable. Without strategy, forget it. This was final words maybe. So thank you.